Hello.
Hi, hope you had a good weekend off and now we're ready to get back into Math World. Yay!
All right. Today we're talking about angles and radians.
Yeah, and you've had angles. You did this in geometry, so some of this is not new and some of it will be because we have to look at it a different way. All right, first of all, you know that an angle is formed by rotating a ray around its endpoint, and we call that the vertex. Its starting position is called the initial side. So if we look at these two angles that we have drawn here, you can see there's our initial side. The final position is called the terminal side. You know, at airport terminal, that's where flights end. They also begin there, but the amount the ray is rotated is called the measure of the angle. Now notice that what we have up here, the top angle is what we call a positive angle, and the bottom angle is a negative angle, and that is because of the direction of the rotation. A positive angle is one where the terminal side rotates in a counterclockwise direction, and a negative angle is one that rotates in a clockwise direction. And now, you remember what we have quadrants 1, 2, 3, 4? I wonder why. Well, because when we start our angle rotation, we start with our initial side on the positive x-axis, and as we rotate it around, notice it goes through the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. That is why the quadrants are numbered in that order. There you go. All right, angles with the same initial and terminal sides are called coterminal, with the same end. So we can look at an angle here, and let's say that's, I don't know, let's make it 70 degrees. Okay? How could we do a coterminal angle? Well, we could do a full rotation around the circle and then 70 more degrees. So how many degrees was that? 360 is our full rotation plus 70 makes it a 430 degree angle. Okay? We can also rotate negatively, but we'll look at that in a moment. Okay, so let's find three angles coterminal with an angle of 30 in standard position. So first we want to draw our 30-degree angle, and there is our angle. Okay? Probably the easiest way is what? To just do one complete rotation of the 360 degrees plus the 30 degrees it takes to get back to the original ending place. So we would write that as 30 degrees plus 360 added on to that is 390. Okay, we can take the easy way out and do two rotations around. So starting again at there's our going up to our 30 degrees, and now do two rotations around from there. One, two.
I'm getting dizzy.
Yeah. And so what did we do? We went up to the 30, and then we added two full rotations from that stopping point. So that's 750 degrees. But there's another way that we really need to not forget about, and that is we can do now negative rotations of angles. And so we start at the positive x-axis again, and this time we're going to go in a clockwise direction. Notice we're not going a full rotation around. So what we're doing is basically going up to the 30 degrees and then subtracting a full rotation, essentially. And that gives us a negative 330 degrees. And if you want to think about it, notice we are not making it a full 360 around in the negative direction. So you need to be able to work with coterminal angles very easily and very quickly in the near future. Okay, so next we have to talk about is some other words to definitions.
So we have an arc, and in geometry you learned that an arc was a part of the circle. Okay, so we've got arcs that are like this thing right here. Remember that? You could find the measure of the arc or the length of the arc, and those are two different things.
Yeah, and that was, remember you learned about it through central angles, and there's length of the arc. And
so a measure of an arc is equal to the central angle of the circle.
If we're in degrees, yeah.
If we're in degrees. And the length of an arc depends on the radius of the circle because it's a part of the circumference. Remember, circumference is the distance around a circle. So arc length can be calculated by taking the degrees of the arc. So like let's say this was 60 degrees. All right, then that would be 60 degrees out of 360 degrees. So this little piece of the pie out of 360 times the circumference of the circle, which is 2 pi r. This is circumference. Okay. Well, I can reduce that. 2 and 360 are common, so I can divide 360 by 2, and that would be theta over 180 times pi over r.
Yeah, and you know what's kind of cool about this is you can also see some relationships that are going to happen here in a few minutes between pi and 180. Now, angles can be measured in degrees and radians. Up to this point, you've really only dealt with degrees. You've heard about pi, but you don't know how pi gets used. And pi is a very important part of dealing with angles. We want to call that radian measure. And the word radian, its root word is radius. So what a radian is it is the length of the radius of your circle measured on the circle. So we basically take the length of the radius and bend it and measure it around the circle.
So what we've done here is we've actually drawn a circle, and I found the radius. The length of the radius is 4.67. That's arbitrary, okay? Then we said, okay, I want to go walk around 4.6 centimeters on the circle and put a dot. Well, as you can see, I measured it and I got really close, like it's perfectly accurate, okay? So B to B prime is 4.67 centimeters. Now I went and did that as many times as I could. So this is 1 time, 2 times, 3 times, and then this little piece right here. Well, I wanted to find out how far it was from here to here in radians or radiuses, okay? How many radius it took me to get to the other side of the diameter. Well, I found out that this little piece was actually 0.14 of a radius. So I found the length times 3 plus the length of this little piece divided by the radius is actually this ratio, 3.14159. So that's really interesting. That sounds like a really familiar number.
Yeah, I think it's pi. Good approximation for pi. So what you see, now let's go back to what we were doing, which was we're going to measure off as many radii. Notice that this is not an equilateral triangle. We have taken the length of the radius and then bent it, curved it so that it would measure off on the circle. So there's one count of 4.67, 2 counts of 4.67, 3, 4, 5, and 6. And if you look at that little piece that's left over, we actually found the length of that, and it's 0.28.
Well, we found the length of it and divided it by the length of the radius to find out what the ratio was.
Yeah.
What fraction was left over.
And it's 0.28, which, you know, that's about a fourth. But more importantly, isn't the circumference 2 times pi times the radius? And what is 2 pi?
2 pi is 6.28.
Oh, so there's our 6 radii plus the 0.28 with respect to the circle. So what you will get whenever you take any circle, no matter how big or how small, and you measure the radius and you count it off around the circle, you will get 6 and a little more than a quarter radii around your circle. That's what the significance of your circumference is.
And what pi is.
What pi is.
All right.
All right, so since our circumference is 2 pi r, when our radius of our circle is 1, then the circumference is 2 pi. So there are approximately 6.28 radians in one circle. Okay? This means there's always going to be about 6.28 radii measured around the circle. Okay? Nice little information for you. Now, a circle centered at the origin has this equation. You should recognize that because x minus h squared plus y minus k squared, where h and k are 0, and it has a radius of 1, and we call this the unit circle. You are going to learn to love this.
Yes.
And the unit circle is our favorite thing, as you're going to see. So an angle in standard position has its initial side on the positive x-axis. It goes through the point 0, 1, and its terminal side is somewhere in the circle. We can see that that angle is clearly obtuse because it's bigger than 90 and less than 180.
All right, so 180 and pi are located at the same place in the circle, as you could tell from our drawings, okay, from over here. Okay, this is pi, and that's 180 degrees, so pi and 180 degrees are in the same spot.
So what we know from geometry is that this is 180 degrees, and what we now know is it's also pi.
All right, so 30 degrees is 180 divided by 6. You should know that. So In radians, 30 degrees angle is pi over 6 because 180 and pi are the same thing. 60 is 180 divided by 3, so in radians, 60 degrees is pi over 3. 45 degrees is 180 divided by 4, so in radians, 45 degrees is pi over 4. All right, so let's talk about converting radian measures to degrees. So to convert theta from radians to degrees, we need to cancel pi out. So we're going to multiply theta, this thing, so pi over 9 times 180 over pi. Because remember, conversion factors, we've got 180 equals pi, so I'm going to put 180 over pi. So that makes these two guys cancel out. Okay, so that's 180 divided by 9. 180 divided by 9 is 20 degrees. So this is 20 degrees. Okay, well let's look at the next one. We've got 3 pi over 5, and we're going to multiply by, since we want to get rid of the pi, we're going to multiply by 180 over pi. So we've got pi's, they cancel. So 5 and 180, we can simplify that. 180 divided by 5 is 30, let's see, that's 36. So we have 3 times 36 is 102. No, 108. 108. Here we go. All right, so we have 108 degrees. All right. Okay, 5 pi. 5 pi times 180 divided by pi. So that's 5 times 180. 180 times 5 is, that's 40. So 40, that's 900. So 900 degrees. Woo, that's a big angle. All right, so we found these degrees from the radian measures. All right, now we're going to convert the following degree measurements to radians. Now this time we want to get rid of the degrees, so we're going to multiply by pi over 180. So 150 times pi over 180. 150 divided by 180, well, the zeros definitely cancel. 15/18 simplifies to 5/6 pi. Ta-da! All right. Next one, we have 330 times pi over 180. All right, so we've got 330 over 180 times pi. So 330 and 180 both have common factors of 10, so that reduces to 33 over 18. 33 and 18 both have factors of 3, so this is 11 over 6 pi. So it's 11 pi over 6. All right, and 540, we have 540 times pi over 180, and 540 over 180, 540 pi over 180, both have factors of 10. 54 and 81 are 18 are both factors of 9, so that would be 54 pi over 18. This would simplify to 2, and this is a 6. 6 and 2 are both factors. 2 is a factor of 6, so that would be 3. So this is 3 pi. Okay, so that's how you do it. You just multiply by whatever is the opposite of what you have. So here I'm dividing by 180 because 180 is degrees, and I'm multiplying by pi.
Okay, now we're going to do one of my favorite things is completing the unit circle. This is going to be, we're going to spend 2 days on this. It is critical that you come to class the next time thoroughly memorizing the relationship between the angles and the radians. For instance, at 30 degrees is pi over 6, where you don't even have to think about it because we're going to layer on top of this in the next class, and if you don't have that stuff committed to memory, next class gets worse. All right.
So what you need to do for your entrance ticket is do numbers 35, 36, 43, and 45 from section 6.3. It asks you to go ahead and change things from degrees into radians.
Yeah, and don't use your calculators. Use your head. Okay. Now, here we go with this is the beginnings of the unit circle, and you will notice on our right margin there, which is at the bottom of your page on your page, is three special triangles that you should already recognize and know and love. Well, we're going to do some relationships with that tomorrow, but what we're going to do right now is start to recognize the relationship between the angles in degrees and the angles in radian. So let's do the easiest angles. These are called quadrantal angles. They're the ones on the quadrants. We are going to write the degrees on the inside of the circle and on the outside of the circle. Now at 0, we have two places, so let's write one above. That's 0 degrees, and all the way rotation around would be 360 degrees. Don't forget that both of those are at that same place. 360 is actually coterminal, correct. All right, and if we go halfway around, we know we're at 180 degrees, and half of that is 90 degrees. And if we just add units of 90, we go 0, add 90 gives us to 90, add 90 gives us to 180, add 90 gives us to 270, and if we add 90, we're back at 360. Okay, now let's go to half of 90.
Are we going to do the pi stuff here?
No, we'll do that after. Half of 90 is 45. So our 45-degree angle, now let's just count off around the circle in units of 45. 45 plus 45 is 90. 135. Add 45, we're at 180. Good. Add 45, we're at 225. Add 45, we're at 270. Yay. Add 45, we're at 315. Oopsie. And add 45 more, and we should be back at 360. Okay, now let's go to 60 degrees. 180 divided by 3 is 60, so we should have 3 of these angles around the circle. 60 plus 60 is 120, plus 60 is 180. There's our third one. Now let's do it again. Add 60, we're at 240. Another 60 puts us at 300. And then adding 60 to that brings us back home to 360. Okay, and now let's go to 30 degrees, which is 1/6 of 180, so there should be 6 of these in a semicircle. If you add 30, add 30, you get to 60, 30 more to 90, 30 more to 120, 30 more to, there's one we haven't done, 150, 30 more to 180. Now keep going. 30 more is 210, 30 more is 240, 270, 300, 30 more, 330, and back up to 360. Now, one of the things that we want you to see is look at these triangles. If you look at this 30-degree angle, that is what we like to call a reference angle. Okay? Notice over here, the 150, if we were to draw a right triangle, and we don't need to draw the whole triangle because it makes messy, but you can see there's our perpendicular, there is our hypotenuse. Do you see that? And notice that the angle formed right here, that is going to be a 30-degree angle with this right here. So this angle I'm looking at. That is a 30-degree we like to call reference angle. So we're going to use some of those relationships in the next lesson. So that's why you really need to understand these things. Now let's count off around in radians. So the easiest ones, again, quadrantal angles, we know that's 0. And we know over here that that's pi. And keep going around, we know that's 2 pi. So half of pi is up here, so that's pi over 2. And if we count off in units of pi over 2, there's 1 pi over 2, 2 pi over 2. Hey, that reduces. 3 pi over 2. And then 4 pi over 2 puts us back. Okay? Now let's go to the 45-degree reference angle.
All right, so notice that 45 is a fourth of 180, so this is actually pi over 4. Then pi over 4, 2 pi's over 4 would be 1/2. Pi over 2. Then 3 pi over 4, that's like 3/4, that doesn't reduce. And then 4 pi over 4, which is pi. And then 5 pi over 4. Then 6 pi over 4, which reduces to 3/2, 3 pi over 2. And then, so that was 6 pi, 7 pi over 4, and then 8 pi over 4.
Which reduces to 2 pi. Good. Now let's go to 60 degrees. Once again, 60 is a third of 180, so its relationship is pi over 3. Counting off in units of pi over 3, there's 1 pi over 3, 2 pi's over 3, yay! 3 pi over 3, way down here we've already got that. 4 pi's over 3. 5 pi over 3 at 300. 6 pi over 3 is right back to 2 pi.
And now to the last ones. Okay, so 30 degrees. Remember, 30 degrees is 1/6 of 180, so that's 1/6 of pi. So 2/6 is 1/3.
And we've already got that.
3/6 is 1/2.
Got that.
4/6 is 2/3.
Got that.
5/6 is, ooh, new. 6/6,
Got it.
7/6.
8/6 pi reduces.
9. 6
Reduces.
reduces 10. Reduces 11/6. Oops, I wrote the pi first. 11 pi over 6. And then 12 pi over 6. And those reduce. So that's how it's easy to memorize the unit circle by these relationships. If you can do it like this, it's much faster than trying to just go around.
Right, and look at the shadowed triangles we've had. If you notice, all we're doing as you move from quadrant to quadrant, for instance, this 60-degree triangle is really just flipped over the y-axis. If we go down here to the 5 pi over 3, it's the 60-degree triangle down here. Okay, so the thing that is, I cannot impress enough, because you're not always going to have time to write out the entire circle and do the relationship between each angle this way. You're going to have to recall it quickly. You're going to have to know that 210 is 30 degrees past 180, so it's 7 pi over 6. You're going to have to get there that quickly. So try to start envisioning those triangles as you move around the circle. That's going to be very, very critical to your retaining the knowledge that you must on unit circles.
All right, now go to section 6.3 and work these problems.
And I might say at this point, of course, no calculators, and you have just filled out the unit circle, but my advice to you would be not to use the unit circle too much as you try to do those each problem.
What I would try to do is draw your own unit circle and try to fill it in on your own.
Yeah, like what if it said negative pi over 4? Where is negative pi over 4?
Well, negative angles go the opposite direction, and pi over 4 is 45 degrees. All right, so that would be right here at 7 pi over 4.
So that's the kind of answer you'll be giving. So some of the problems might have you do things like that. So just use your head and try very hard. These problems shouldn't take long.
All right, one new thing you learned, one good question, 2 old skills that are important for recall. And don't forget to bring your entrance ticket. Bye.
Bye.